Hi everyone. We had dived into the basics of NumPy, Pandas, and scikit-learn, and Matplotlib as well. Now today, let's see how can we use linear regression to work on a dataset. So I am using this dataset, student performance dataset, and herein we have around 33 columns, wherein the data is can be seen. Data is something like this: school, the type of school, sex, age, address of the student, family size, P status, mother's education, father's job, mother's job, and so the basically the target variable that we have to predict here is actually the grade that the student will eventually score. So let me just show you. Um, uh, Yeah. So basically, this is what the data looks like exactly. There are basically three grades. So grade 1 and grade 2. But our target variable that we have to predict is grade 3. That according to these columns, how much um, a student will score in third grade. So yeah, let's quickly jump into it. I'm going to quickly open my command prompt and we'll be working on Jupyter Notebook. I've already made a tutorial on how to install Jupyter Notebook. So if you haven't watched it, go watch it. So if you type Jupyter Notebook on your command prompt, it'll open a Jupyter Notebook in your browser. So as you can see, my Jupyter Notebook is now open. Um, just a second. Yeah. Now go to New and click on Notebook. This will open a Jupyter Notebook wherein select this kernel, wherein you can actually perform operations on your dataset. Now, since I've already made this notebook, I will be closing this. But in order to understand it, the whatever operations I've done more clearly, I recommend that you code along with me, along with whatever is written here. So yeah. Now moving on, go back to your student performance dataset and click on download. So as you can see that this will actually download a zip folder. And next what you have to do is click on extract all and select the folder where you want to extract your student data. I have opened this folder since I already have this folder in my PC. So I'm just going to click on replace. As you can see that this CSV file is present in my desktop for now. Okay, so next let's move to the notebook that you have opened. Now I have started by obviously importing some necessary libraries: pandas, numpy, matplotlib, and seaborn, like I told you. Next, just a second, let me just share the Jupyter notebook only. Mm, mm, okay, just let me check. Yeah. So I have started by importing some necessary libraries. Next, I am reading the data using pd.read.csv. In order to do this, um, let me share my screen once again. So in order to do this, move back to your folder where you downloaded this file. Next, right click on it and select copy as path. Now, move back to your Jupyter notebook and between these double quotes, copy this column, copy this path, hit Control V, and um, now as you know that backslash something is considered as a special character in Python, therefore you need to change it to double backslash. Now, in order to run a cell, this is actually called a cell. So, in order to run the cell, hit Shift Enter. Yeah. So your date, and if you um if you write data, then you can see that you have the data set um, in your data variable. Now, in the next line, I quickly changed it to a data frame, since, as I told you, working on a data frame makes you have a lot more commands. So, using pd.dataframe, I have changed it into a data frame, and now I'm writing df, and basically, df gives me the data set in the data frame. Next, for the sake of ease, I am only using 7 columns here. You can select on your own, or based on some operations, based on some other predictions, other requirements, you can select other columns as well. But for now, for the sake of ease for learning, I have selected only 7 columns: sex, age, address. uh, just a second, I will be selecting male, father's educations, mother's education, and father's education. So, and G1 and G2. So these are the columns that I have taken. Next, I am since my data frame already, this df variable already has a lot of columns, all the columns basically. So next, I will be converting this to another data frame that has only these columns. So this is how you have to do it. Um, I have created a new data frame, df2 equal to this df and another variable. So all these basically column names. Now if I hit df2, as you can see that now my df2 only has the columns that I'm working on. Therefore, this is a great way to basically select the columns that you want to work on. Okay, next, let's move to understanding how you can uh, understand your data nicely. So let me just write df.shape. Like I told you, it returns a tuple, which shows that my data set has 395 rows and 38 columns. Actually, I am working on df2. So let me do df2.shape. Now, as you can see that my df2 has, as it is saying here, 395 rows and 7 columns. Okay. Next, write df.info. So my df.info actually returns, like I told you, it returns things like non-null, count, and d-type. So basically, let me just write df2.info. Yeah, so it is clearly saying that my sex column is actually an object, and age is actually int64. Therefore, I can clearly see from here that my sex and age, these two columns are object, which means string. As I told you already, rest all my columns are basically integer. Actually, I also have to take G3 here, because basically we have to predict G3. So let me just go ahead and write G3. Yeah. So you also have to work on G3, since G3 is the target variable, right? So, and it also shows that my G3 is int64. So let me do df.describe now. So df.describe, as I told you, returns some basically statistical analysis. It tells me the mean age that I have is around 16 years. And let me do df2.describe. I'm okay. Now it is telling me that the mean grade that students have scored is around somewhere around 10.9 in the first part of the grading. In the second part, they have scored around 10.71, and the minimum that is 3 in first grade. Next, it's 0 and 0. So yeah, it is showing things like that. Now let's do df.sample 5. So df.sample, just a second. Df.sample actually enables me to um, get an idea about what my data looks like. So guys, as you can clearly see that um, that sex and address are actually objects, right? So These are these may be categorical columns. If so, let's check if they're categorical or not. Df of um, address dot value underscore counts. So this returns the number of uh, occurrence of one type of entity along with its count, and another type of entity along with its count, right? So it is telling me that urban, that the address, that is people living in the urban areas are more, that is 307, and people living in the rural areas are less, only 88. So this is how I can see that my address is categorical. And let me just do this for uh, this column as well. It's telling me that females are more and males are less. Yeah, so this clearly proves that yes, these are categorical columns. Now next you can also try running some more functions on your own. I will leave you for that. Now next understanding, next let's move to what actually linear regression means. Let me just present this slide. So basically, linear regression is a kind of uh, supervised learning wherein you have one variable and you have to predict another variable, such that between those two variables there is a linear relation, right? So as you know, the linear equation is y equal to b plus mx, but some error term is also added here. uh, I will show you what this error term basically means. So this error term is actually this. Let's say I had my model and it is predicting this line. So this is your error. Like at this point, this is the correct predict. This is the prediction that my model is making. But the correct correct prediction is this. So this is my error, right? So this is what it means. Next, this is actually the y-intercept, and as you know in maths, this is the y-intercept and this is the slope, right? Now moving on. So these are some formulas that we use while calculating the coefficient of x and the intercept, that is the slope. You'll eventually learn this whenever you move to higher mathematics. For now, let's leave this. Next, moving to the assumptions of linear regression. So linear regression assumes that among your feature variable and your target variable. So feature variable is actually the input. Let's say let's take an example of months and your income. So let's say in January you had 10,000 rupees. In February you had 30,000 rupees. In March you had 40,000 rupees. So yeah, this way linearly your income is increasing. So your uh, basically your independent your y and x, basically your income and month for example, should have a linear relation here, no multicollinearity. So basically this means that among your variables there should be, let's say we have one more um, feature here along with your income and months. Let's say health. I have a column of health. So your health, let's say, was not very good. Then it start gradually, some your heart points start increasing, things like that. Let's just suppose that. So there must be no relation between your health column and your months column. There is no relation, right? Here, there is no relation. So between these two, like I said, there should be no relations. Next, moving to residuals must be distributed equally. This basically means that the errors that you are having should be distributed equally. You need not to focus much on this for now. Now, first of all, let's go back to some pre-processing steps we have to do. Now, as you can see that here, um, you cannot pass male M and F as an input to your model, right? Because obviously your linear regression model is expecting a numerical value. So it is nice that you convert these values back to integer, right? So these are the steps that come under pre-processing. So pre-processing steps basically means before giving your input to your model, you perform some pre-processing steps in order to make your data set just a little better and basically compatible. Okay. Now, as you know that sex and address column are um, categorical columns, right? So they contain objects, strings. But your linear regression model will obviously be expecting um, what you can say numeric values, right? So now let us start by converting these columns to numerical. So for that we use something called get dummies. Let me just convert this to a markdown. So we for that we use something called get dummies. So get dummies actually convert our uh, column into two columns. For example, let's take address. So this address will be converted to two columns, that is address urban and address rural, and beneath these it will contain true and false values. Guys, this is done such so that so that there is absolutely no multicollinearity um, introduced in your dataset. However, you can change this to 1 or this to, for example, U to 0, R to 1 manually. But I recommend that since multicollinearity should be avoided, I prefer using this method. So how to do this? So we'll write df.encoded equal to pd.getDummies. Let's do it for sex variable first. So df of uh, that this column and prefix equal to the name of the column. Close the bracket. Now let's press shift enter. Let's see what this has. So as I told you, this uh, sex column has been changed to two columns since we only had two male and female here. Therefore we'll get two columns only. Let's say if we had non-binary or transgender, then it may be converted to three or four columns, right? So for now only we have only these two columns. Okay, so this actually converted uh, your these two columns and gave true and false values. So this is actually a very good method to convert your categorical columns back to numerical. Now you might be wondering that true is not numerical. So we'll later we'll definitely come back to that. For now, just understand that this has been converted to these two columns. Now we have to add these columns back to our original data set, right? This. So how to do that? Now let's move on. Let's write df equal to df dot um df equal to sorry pd dot concat df comma df underscore encoded and axis equal to 1 because we are working on a column, right? So what pd.concat does is that it concats the uh, two data frames together. Since we have to combine this back to our original data set. Therefore this is what we'll do, and obviously I'm going to write df2 here since I'm working on another data set. Sorry. So yeah, uh, let me just add a few more rows. Okay. Now, as you can see that we have successfully um, added these two columns back into our original data set. Now we have to do the same for our address. So I am just going to copy this and I'm going to paste this here, and I'm going to change it to address, and I'm going to change it to address here as well. Okay, and let me just copy this again. X is equal to 1. Yeah. So let's press shift enter. Let's do df2. And as you can see that my address column has also been converted to address rural and urban. Say we had another column here, it would be converted back to it would be like rural urban, or let's say some very high class high societal area. So we'd have three columns, but since we only had two columns here, like I told you, therefore only two rows will be there. Okay, now about how to convert this back into integer. Now, as you know, in Python, false is generally false is taken as 0 and true is taken as 1. So I am going to do df2 equal to df2 dot as type int. Oh, it's throwing some error. Just a second. Oh, actually, guys, since this variable is still present in our data set, therefore the string cannot be converted to um, integer directly. So obviously now you know that these two columns are now they are not needed. Therefore, let me just drop these columns, and in order to drop these columns, basically you have to do um, x equal to df dot drop. Let me just store it in a variable x, columns equal to, and pass your columns as a list. So address, yeah. Now let's look into our data set once again. Oh, I have to drop df2 actually. Now let's look in, yeah. So as you can see that the original section address are gone. Now let's convert it back into int x equal to x dot as type int. Now let's look into our data set. Yeah, now you can see that these true and false values are changed to integer. Now moving on, we can see that all of our columns have been changed to integer. Therefore, it is now we'll move to model making once again. Actually, back before model making, let's do some visualizations. Now, like I told you, you can leverage Seaborn for making visualization. Vis so basically, visualizations help you to look into your data set. Now here I have drawn a bar plot between sex column and the G1 column. Now as you can see that in G1 part, males are scoring slightly higher than females. So yeah, these are some insights that you can get from your data by using these visualizations. Next, moving on, I have drawn this line plot which suggests that according to the as the age is increasing, first the G2 grade decreases, then when age between 19 and 20 it suddenly increases, then it starts decreasing again. So this suggests some trends between age and G2. Next, I am moving to drawing a hist plot between age. So hist plot tells us what is the count of the different numbers, different ages. So we can see that age group of 16 is actually the most prevalent, and 21 and 22 is the least prevalent. Now, moving to a line plot between G2 and G3. So as you can see that there is this very strong linear relation between G1 and G2 and G3. Let's do this for G1 as well. So you can see that there is actually another very strong relation between G1 and G3. So yes, it is confirmed that we can apply linear regression here. Next, moving on to count plot. So basically, I wanted some insights how living in different addresses like urban and rural can affect G3. So I here I made a count plot, sns.count plot, and as x I passed my address, and as uh, so like I told you, hue function is actually used to, basically it's not a function, it's a parameter that is used to get output of this value according to these values, right? And to make it a little more presentable, I changed it to another color palette. So let's run this and see what we are getting. So as you can see that G3 uh, grades have been uh, um, what you can say given different colors, and urban and rural. So these are plotted, and these some count plots are plotted. Now as you can see, the frequency of 18th grade, 18 number in G3 is extremely high in urban areas, which clearly suggests that people in urban areas are actually doing collectively better than people in rural areas. You can see that the all over grade is also smaller. This bar is very high, but as these bars are low. So you can uh, get this insight that yes, people in urban areas are actually doing way better than rural areas when it comes to grade. So yeah, these are some insights that you can get. Now, let's move on to model making. So, okay. Now, like I told you, there are some feature columns, input columns, and some output columns, right? So let's start by separating those. Now, as you can see that herein, let me just copy this. As you can see that here I dropped columns like, first let us see what our df2 looks like as of now. So, guys, actually, I have dropped these columns and stored this in X. Therefore, there will be no changes reflected in df2. df2 is still going to have these columns. So, uh, now in my model as an input, I want to pass only these values as well as age, mother's education, father's education, G1 and G2. I don't want these sex, address, and G3, because G3 I have to predict G3, therefore G3 will not go in X variable. So let me just add G3, right? And let me again change my X into integer variable as type int. Okay. Now for my y-axis, that is, I told you there are two variables, X and Y, right? X is your independent variable and Y is your target, your feature, your column that you have to predict. So what column I have to predict? I have to predict G3. So I will go ahead and write df2 of G3. Yeah. So let's run this now and let's see what is in our X. So as you can see that X contains these columns and Y will only contain G3 column, right? Now let's start by uh, using scikit-learn for our model making. Just a second. Now for model making, guys, let's start by using scikit-learn. So I am going to type from sklearn dot model selection import train test split. Next, from sklearn dot linear model, by using sklearn dot linear model, we can import a linear regression library. and then I am just going to import some matrix that will help us understand that how good our model is performing. So mean squared error. Now let's run this. Uh, Actually, it's mean squared error, SQUA. Okay. Now you can see that this is successful. Next, uh, guys, as you know that there is actually a training dataset and testing dataset. So basically, what that means is that from your data set that you are working on, you have to divide your data set into some training part and some testing part. So the training part of your data set will contain columns that will help you train your model, and the test part is actually to be hidden from your model. The test part will help us in evaluating how our model is actually performing. So test part has to be hidden, and the training part has to be on the training data set. Your model has to be trained. Okay, so uh, generally what is done that 70% of your data set goes to training and 30% is hidden from the model. So using that 30% data, we can test our model, that how our model is performing. So I am going to do just that. So I'm going to type x train, uh, x test, comma, y train, and this is done also done for your feature variable and your uh, target variable. So I have done y train here, since some of this data is also to be hidden and also for this data. So y train, y test equal to this train test split helps us in doing just that. Now I am going to pass my x, that is my input features, and my y, that is my output feature, and then I'm going to close this. Okay, now if you want to specify that no, maybe you have some different requirements and you want to use 80% of your data, so for that there's a parameter called test understroke size equal to 0.2. Now here you are specifying that the test size that you want to use is actually 20%, right? So here you are specifying that you want to use 20% of your data for testing your data. That is 80% goes to training. Okay. Now let's start by creating a object for our linear regression. So model equal to linear regression. Next, let's do model dot fit. So by using model dot fit, you actually train your model to on your training data. That is, you are teaching your model how to basically classify or how to perform whatever operation that you are giving. So model dot fit just that does just that. Since it is linear regression, so it will train the model according to linear regression. Okay, so x train, comma, y understroke train. Now our model is trained. Okay, and now it's time for prediction. Now I am going to type y pred equal to model dot predict. Now as you know that X test is actually the amount of data that was hidden from our model, right? It is the testing data. So now I have to predict this test data. My test data will contain these variables. That is, it will contain X. Let me show you. So these are the variables that my X test will also contain, but it will not contain this variable because it is the testing data and this variable has to be predicted, right? So let's do X test and see what happens. Let's type ypred So ypred actually returned a numpy array wherein these, according to these input features in my X test, G3 grade has been returned. Okay, now let's get some metrics about mean squared error as well. So mean squared error is actually the amount of error that you are getting. So I'm just going to write MSE equal to mean squared error y test, comma y pred. Why I have given y test? Because you might be wondering, why have you given y test? Because y test will contain, here in y test will contain this part, G3 part of the data that has been hidden from our model. Because until and unless you give your model y test, it won't be able to predict how much error you are getting. And y pred is the predicted uh, outputs that the model has given, and y test will contain the correct output, the actual output of the model, right? So I am going to just a second. I have okay, it's actually small y pred. So around 2.52 is the error that I am getting for my model. Once again, I am going to repeat this. Ypred will contain the predicted values of G3, and ytest will actually contain the correct values of G3 that are actually present in the dataset. Okay. Next, moving on. We'll see how to check the accuracy of our model. Now, I am going to import R2 score. So R2 score is actually a matrix. You for now don't go into detail about what R2 score actually is. So R2 score is a metric that is mostly used to check accuracy for linear regression models. So let me just type R2 underscore score um, y test, comma ypred. So so basically we are getting R2 score as 87%. Just a second. So guys, basically R2 score tells us the goodness of fit of the model. That is, yes, 87% of the data is correctly fitting. Next, moving on to how you will eventually later see how you can also deploy this model. Yeah. So you can see that around 87% of our data is fitting perfectly. So yeah, that is basically it for this. Let me just repeat some of the points once again. Uh, okay, guys, next moving on, let me give a quick recap of whatever we did here. So basically, we imported the dataset using pd.read CSV. Next, we are using only 7 variables here for the sake of ease of use, 8 variables actually. Next, we did some pre-processing steps wherein we converted our categorical data back to numerical data, and we saw some visualization. And you can also change these according to whatever relation that you want to get. Next, we performed model making, wherein we dropped these three columns since these were not needed during our training time, and we in our y variable we stored the model that we wanted to predict. Next, we imported these libraries, train, test, split. So training data is actually the data on which your model will be trained, and testing data is the data wherein your model will be checked that how your model is performing. Next, we created an object of the linear regression class, and then next we did model.fit. Using model.fit, you can train your data. Next, we did model.predict, wherein the model is actually predicting the values, hidden value, the values of the hidden data set, that is our X test. And now Vibrate contained the uh, array, numpy array of the values that it had predicted, G3 values, and MSE is used to check the error that basically we are getting, that is 2.52 grade. This amount of grade is the error that we are getting. Next, we imported R2 score, and we are getting R2 score as 87, which R2 score, which basically depicts the goodness of fit. That is 87% of your data is fitting perfectly. So yeah, that is basically it. Next, we'll see how to deploy this model using Streamlit. So yeah, thank you for now.